So for this problem, we want to use the results that we got from problem 2.7 to find the field inside and outside of a solid sphere of a radius r that carries a uniform volume charge density of rho. We're going to express our answer in terms of the total charge of the sphere, Q, and draw a graph of the magnitude E as a function of the distance from the center. So to start with our results, from 2.7, we have E of R is equal to 1 over 4 pi epsilon naught times Q enclosed R squared times R hat, where Q enclosed is equal to the function rho VR is equal to Q over 4 over 3 pi big R cubed times 4 over 3 pi R cubed, which is simply equal to Q over R cubed, and that is if little r is less than big R. Then we have rho V big R is equal to Q over 4 over 3 pi big R cubed times 4 over 3 pi big R cubed, which is equal to Q, and that's if little r is greater than big R. So then we found that E is equal to 1 over 4 pi epsilon naught big R cubed times Q over R cubed times R hat if R is less than big R. Then we have 1 over 4 pi epsilon naught R squared times R hat if R is greater than big R. So now we want to plot our graph. So this, our y-axis will be ER, and this x-axis will be R over R. And for big R, we will have a linear graph to our maximum ER, and then for little r, it'll be an exponentially downward graph. And our maximum will be 1 over 4 pi epsilon naught times Q over big R squared. So that would be that point here. And this will be little r, and this will be big R. So now we just want to sketch point of a solid ball. So we have our z-axis, our y-axis, and our x-axis. And we have our ball in the middle. And we have a point on the ball that will be x, y, z. And you'll see to a point z above. So it'll be 0, 0, z. And the radius of this will be r. So then we take our formula and we get E equals 1 over 4 pi epsilon naught times the integral of rho r naught over r cursive squared, r cursive hat, d tau, which is equal to 1 over 4 pi epsilon naught rho over r and the magnitude of r minus r squared. It's r minus r minus r magnitude d tau, which ultimately equals 1 over 4 pi epsilon naught into a rho r naught r minus r cubed r minus r d tau. So now we want to just take the triple integral. So it would be E is equal to 1 over 4 pi epsilon naught triple integral x squared naught y naught squared plus z naught squared less than r less than equal to r. Then we have rho over the square root of 0 minus x squared plus 0 minus y squared plus c minus z squared. All times the vector, so multiply times the vector, is 0, 0, z. The two vectors that we had, that distance between this vector here and this vector here. So it'll be x, y, z, d, v. Now we find r, which is equal to r cosine phi sine theta. That'd be sine phi sine theta cosine phi. We put it in spherical coordinates, and we get 0. Plus then r less than or equal to r less than or equal to big R. Zero less than or equal to phi less than or equal to 2 pi. 0 less than or equal to theta. Less than or equal to theta. Less than or equal to pi. So now to find the electric field at R, where R, again, R is equal to 0, 0, Z. E is equal to rho over 4 pi epsilon naught. We want to take the triple integral, so 0 to pi, 0 to 2 pi, 0 to big R. And we have 1 over square root of 0 minus r cosine phi sine theta squared plus 0 minus r sine phi sine theta squared plus z minus r cosine theta squared, all times the vector of 0, 0, z minus r cosine phi sine phi. Sine theta sine phi sine theta cosine phi. So r squared sine phi dr d phi d theta. So from there we can simplify more and get rho over 4 pi epsilon naught. So the same triple integral with the same limits. 0 over 2 pi, 0 over r, and get 1 over r squared sine squared theta plus z minus r cosine theta squared, all of that to the 3/2 times the vector negative r cosine phi sine theta minus negative r sine phi sine theta z minus r cosine theta times r squared sine theta dr d phi d theta. And once we simplify that more, we get rho over 4 pi epsilon naught. And I'm sorry if my rows look like p's. 0 to pi, 0 to 2 pi, 0 to r cubed cosine phi sine theta over r squared sine squared theta plus z minus r cosine theta squared to the 3/2 dr d phi d theta minus, I have to use 2 lines, minus triple integral Well, that'll be the first part of the vector, I'm sorry. Minus 0 pi, 0 to 2 pi, 0 to r. We have r cubed sine phi sine theta over r squared sine squared of theta plus z minus r cosine theta squared to 3/2 d r d phi theta. And our last part of that vector would be 0 to pi, 0 to 2 pi, 0 to r squared, z minus r cosine theta, sine theta, all over r squared sine squared theta plus z minus r cosine theta squared to 3/2 dr d phi d theta. After simplification, we get rho z hat over 2 epsilon naught 0 to r pi z, yeah, r squared z minus r cosine theta sine theta r squared minus r squared cosine theta plus z minus r cosine theta squared to 3/2 d theta dr. Now we just use u sub where u is equal to z minus r cosine theta. So du will be r sine theta d theta. And from that we get rho z hat 2 epsilon naught 0 r from z minus r to z plus r u 2zu plus r squared minus z to the 3/2 du dr and once we plug these back in, once we plug u back in, we get q over 4/3 pi r3 times z hat over 4 epsilon naught z squared over 4x cubed over 3 if z is less than big R. Otherwise, we get q over 4/3 pi r cubed times z hat over 4 epsilon naught z squared times 4r cubed over 3 if z is greater than big R. So our final solution for the electric field at R 0, 0, Z is E is equal to 1 over 4 pi epsilon naught Q over R Q Z hat if Z is less than R, and then 1 over 4 pi epsilon naught Q over Z squared Z hat if Z is greater than R. Thank you for watching this video.